Digital radiography includes two things, CR and DR. So CR is computer radiography and DR is digital radiography. So now I will talk about the digital radiography. Digital radiography is a digital imaging process where FPD, that is flat panel detector, is used instead of any film screen or PSP, means personal software process technology. Uses X-ray sensitive plate to directly capture the data during the patient examination, immediately transferring it to the computer system without the use of any intermediate cassette. No cassette is used. The X-ray heat are permanently placed of hardware. So there is one hardware which is placed just behind the patient, and X-ray was exposed and directly captured by the hardware. Not captured actually, the image was immediately transferred to the computer, that is directly to the PC. The photon acts directly on a photoconductor layer, producing a positive and negative charge. There is a photoconductive layer which produces positive and negative charge in response to photon. The positive charge is attracted to a charge capacitor. There is one charge capacitor. So the positive charge is attracted to charge capacitor that stores the latent image. So basically the charge capacitor restores the latent image, not stores. It is read out by TFT and a thin flat transistor switches pixel by pixel. So there is a TFT, thin flat transistor, which switches pixel by pixel, and it is read out immediately. So it is of two types, direct and indirect. In case of direct, use of amorphous selenium, and in case of indirect, use of amorphous silicon. Selenium, silicon. Direct is selenium, indirect is silicon. So use amorphous selenium, which converts information of the X-ray photon energy to the electron directly. So here amorphous silicon is used, and which converts directly X-ray photon into the electrons. But in case of indirect, what happens that there is conversion of X-ray photon into light converted into electrical signal, that is electrons, and which is shown in the computer. So use amorphous selenium, which converts information of the X-ray photon energy to the electron directly. Avoid noise conversion, no intermediate light, the signal is transferred through the electrical charge, and it has very good spatial resolution. So X-ray first conduct with the photoconductive layer, which is coated with amorphous selenium. What do you mean by amorphous? Amorphous is it's almost like a gel uniform substance, which is not like a grain. Usually whatever the element we are using, it's in the form of solid, so it will be, if grain, then X-ray quality will not be produced, it will be distorted. That's why amorphous is used. So photoconductive layer, that is selenium, and from photoconductive layer it goes to the TFT, that is thin film transistor array, and it is captured by the computer, that is direct conversion. So X-ray exposure on high voltage, then semiconductor made up of amorphous selenium, then X-ray photon is converted into electron, and electron is captured by the TFT, thin film transistor array, and which is produced into the digital image. In indirect digital radiography, indirect FDP, use of amorphous silicon detector. It has cadmium iodide phosphor, which are first, and we have read cadmium iodide also on the fluoroscopy image intensifier. So it has cadmium iodide phosphor, which at first convert X-ray photon energy to the light. The phosphor is coupled with amorphous silicon panel incorporated in or TFT thin flat transistor array, which convert light energy to the electron. So here is use of phosphor like computed radiography. But phosphor is coupled with amorphous silicon panel incorporated in a TFT array, which convert light energy to the electron. So it provides image resolution of 100 micrometer. What is the steps by steps? There is in case of indirect X-ray, each X-ray photon is given to the patient. There is two type of conversion. One is scintillator based, another one is charge couple device. So charge couple device is old method. It's not using that much now, but it is used in also in case of fluoroscopy. So what is the old method? Charge couple device. It contains lens and optic fibers which convert light photon into electrical signal and send it to the computer. Whereas in case of scintillator, that is calcium iodide photodiode is present, and from photodiode it goes to the TFT. And there is three things which we have mentioned in the introduction. There is pixel, that is captured image, capacitor store charge and produce latent image, and switch causes discharge of the electrical signal step by step. So pixel, capacitor and switch in case of scintillator way. In case of charge couple device, it goes to the lens and fibers optics, and which convert light into electrical signal.